For conditional statements, the symbol, a rightward pointing arrow, or any of the following words imply conditional. Then, if, sufficient for, necessary for, and only if. For conditional statements, they are false only when the antecedent is true and the consequence is false. Well, to put it more simply, if you have T, right arrow, F, you can also look at it as T implies F, true implies false, then it will be false. For all other statements with a right arrow, they are true. For biconditional statements, the symbol, a left and a right arrow, or the words if and only if represent biconditional. Biconditional statements are true only when the component statements have the same truth value. Again, more simply put, if you have T, if and only if T, or F, if and only if F, then they are true. All others with the left-right arrows are false. Again, when working with truth tables, you have a binary choice. You only have two options. The statements are either true or they are false. You have no third option. So with that, let's look at some examples. So we have not P implies Q. So again, we have our truth tables, P and Q. So TTFF for P, and then Q is TF, just alternating for that. So not P, so not true is false. Not true is false. Not false is true. And not false is true. Again, negation, very easy. Now let's do the implication, or the conditional. So not P implies Q. So false implies true. Well, we know that from up here, T to F, true implies false, is the only one that'll be false. Everything else is true. So false, and it has to be in this order, not P implies Q. So false implies true, which is true. False implies false, true. True implies true, it's true. And then true implies false is T to F. This is false. For everything else, it is true for this conditional statement. Now let's look at a biconditional statement. Not the quantity P if and only if Q. So what I've done is I have taken the inside, the P if and only if Q, and I have put it in its own column, and then I've done the entire thing for the last. So again, P and Q, TTFF, Q, TFTF. So P if and only if Q, so true if and only if true, so T if and only if T, which is true. T if and only if F, again we know up here, T to T, F to F, when it's a biconditional, is the only way they're true. Everything else is false. So since these are not both the exact same truth values, this is false. Same thing here, F to T, this is false. And then F to F, this is true, because they're both false. But we're not done with this one. This one actually has the negation of the whole thing. So we're just going to negate this entire column. So the negation of true is false. The negation of false is true. The negation of false is true. And the negation of true is false. And that's an example of the biconditional. Now we're going to have both biconditional and conditional in one statement. So here we go. I've taken the biconditional, P if and only if Q in here, and then I put the conditional whole statement here. So true if and only if true is going to be true. True if and only if false is false. False if and only if true, false. And then false if and only if false, true. Because they're both true or both false, the other two have to be false. Now we're going to do the implication. P if and only if Q implies Q. So true implies true. True. False implies false. True. False implies true. True. And then true implies false. because it is the only one that would give us a false statement. T implies F. This one is false. So you can even have both biconditional and conditional statements in one truth table, but we don't treat it any differently. We just take it each piece at a time. So here are the examples for biconditional and conditional truth tables.